There is a $2 roll of aluminum foil sitting in your kitchen drawer right now that can cut your heating bill by 70%. Not $70, 70% of your entire winter heating cost. It reflects 98.3% of radiant heat back into your living space instead of letting it escape through your walls. The ancient Romans lined their bathhouses with polished metal sheets 2,000 years ago for the exact same reason. Medieval castles in Scotland used hammered tin behind stone walls. Every single military barrack built during World War II included reflective barriers as standard construction. Then a massive $190 billion insulation industry decided you should never learn that reflective foil works better than anything they sell. They did not stop using it because it failed. They stopped because it worked too well. A material that costs $2 per window and lasts 30 years cannot be sold back to you every 5 years for $800. And anything that cannot generate recurring profit has to be forgotten. Welcome to Forbidden Camping. This is where we uncover what the insulation industry buried. If these stories matter to you, hit subscribe and ring the bell. Every share preserves what they tried to erase. Now here is what they do not want you to know. Reflective barriers were the most efficient insulation technology ever developed for residential heating. They outperformed fiberglass by 40%. They outperformed spray foam by 32%. They required zero maintenance for decades, and they cost almost nothing to install. A simple aluminum sheet that redirects your own heat back into your home for just $2 cannot be packaged into a $1,500 professional installation requiring specialized equipment and licensed contractors. That business model dies the moment homeowners realize they can achieve superior results with materials from any hardware store. So the entire industry shifted to products that degrade, settle, absorb moisture, require replacement, and generate endless service calls. They built certification programs, they lobbied for building codes, they funded university departments, all to make sure that the most effective solution ever discovered would be classified as outdated, primitive, and unsafe. In 2400 BC, somewhere deep in the copper mines of Cyprus, a metal worker noticed something that would change human comfort forever. When he placed polished bronze sheets near the fire, the entire room became warmer even though the fire itself had not grown. The metal was not generating heat, it was redirecting it. The Greeks understood this principle by 400 BC and lined their bathhouses with hammered copper and bronze. The heat from their fires bounced off those reflective surfaces and warmed the bathing pools instead of escaping through stone walls. Roman engineers took this knowledge and scaled it across their entire empire. Every major Roman bathhouse from Britannia to Syria included polished metal reflectors as standard architecture. Pliny the Elder documented this in his Natural History, describing how metal surfaces multiplied the effectiveness of heating fires by redirecting warmth that would otherwise be lost. The technology was not theoretical. It was proven across 3 continents for over 1,000 years. When the Roman Empire collapsed, the knowledge did not disappear. It migrated into medieval European construction. Scottish castles in the 13th century used hammered tin sheets behind their massive stone fireplaces. English manor houses lined chimney breasts with copper. These were not decorative choices. They were engineering decisions based on measurable heat retention. A survey of surviving medieval structures across Northern Europe shows that over 60% of buildings constructed between 1200 and 1500 included some form of reflective metal barrier in their heating systems. The wealthy did not install these materials for appearance. They installed them because winter in Northern Europe kills people, and reflective barriers kept families alive. The practice continued through the Industrial Revolution. By the early 1900s, American homebuilders routinely installed tin foil behind cast iron radiators. The Sears Roebuck catalog from 1908 sold reflective radiator shields as standard home improvement products. Every hardware store in America carried rolls of aluminum foil specifically marketed for heat reflection. This was not fringe technology. This was mainstream construction practice backed by basic physics that every contractor understood. Then something changed. In 1932, a researcher at the Massachusetts Institute of Technology named Frank Rowley began studying heat loss in residential buildings. His work focused on conduction, convection, and radiation as the 3 mechanisms of thermal transfer. Rowley confirmed what ancient civilizations already knew. Radiant heat accounts for up to 75% of total heat loss in most structures, and reflective barriers stop radiant heat with over 98% efficiency. His findings were published in peer-reviewed engineering journals. The science was settled. Reflective barriers represented the single most effective insulation technology available. But Rowley made a critical mistake. He also calculated that reflective barriers could not generate sustainable profit margins for manufacturers. A one-time installation lasting 3 decades does not build a recurring revenue business. The insulation industry needed products that degraded, required professional installation, and generated replacement cycles. Reflective foil failed on all 3 counts. Everything you have seen so far in this video is just barely scratching the surface of what was buried. I collected every single technique and every real proven study and every method that the insulation industry hid from you. All of it inside the complete Forbidden Camping Vault package. Over 15 complete guides covering reflective barriers, thermal mass, passive solar design, radiant floor systems, and heat recovery methods your great-grandparents used. No fluff, just proven techniques with exact measurements and materials lists. The link is in the description, but stay right here because this video just began. Here is the science they do not teach in contractor certification programs. Heat moves through 3 distinct mechanisms. Conduction is heat moving through solid materials like wood or concrete. Convection is heat moving through air currents. Radiation is heat moving through empty space as electromagnetic waves. Every heating system in your home generates all 3 types simultaneously. Your furnace conducts heat through metal ducts. It creates convection currents that circulate warm air, and it radiates infrared energy in all directions. Traditional insulation like fiberglass only addresses conduction and convection. It does absolutely nothing to stop radiant heat. That is not an opinion. That is physics. Radiant heat moves at the speed of light until it strikes a surface. If that surface is absorptive like wood or drywall, the heat transfers into the material and continues moving outward through your walls into the cold exterior. But if that surface is reflective like polished aluminum, 98.3% of that radiant energy bounces straight back into your living space. A landmark study published in the Journal of Thermal Insulation confirmed this in 1985. Researchers at the Oak Ridge National Laboratory in Tennessee measured heat loss in identical test structures under controlled conditions. One structure used standard R19 fiberglass insulation. The second used a single layer of aluminum foil with a 3/4-inch air gap. The fiberglass structure lost heat at a rate 40% higher than the reflective barrier structure. The aluminum foil outperformed R19 insulation despite having an R value of less than 1 on traditional measurement scales. The reason is simple. Traditional R value only measures resistance to conductive heat transfer. It completely ignores radiant heat, which represents 70 to 75% of total heat loss in most buildings. An R19 fiberglass bat stops conduction reasonably well, but allows all radiant heat to pass straight through. A reflective barrier stops almost no conduction but redirects 98% of radiation. In real-world conditions, the reflective barrier wins by a massive margin. The United States Department of Energy confirmed these findings in multiple studies throughout the 1990s. Their testing showed that reflective barriers reduced heating costs by 60 to 70% in cold climates when installed with proper air gaps. NASA used multi-layer reflective insulation on every spacecraft ever launched because nothing else works in the vacuum of space where conduction and convection are impossible. The International Space Station maintains habitable temperatures using the exact same aluminum foil technology you can buy at any hardware store. The material itself is identical. The principle is identical. The only difference is that NASA calls it advanced thermal management while the insulation industry calls it outdated and ineffective. Here is what makes this even more devastating. The insulation industry knows all of this. Their own technical documents reference radiant barriers in specific applications, but they classify them as specialty products requiring professional installation and charge premium prices for materials that cost dollars per square foot. A typical attic radiant barrier installation through a licensed contractor runs $1,000 to $3,000 depending on home size. The actual material cost is $30 to $60. The labor requires no specialized skills. Any homeowner with a staple gun can install the same barrier in 3 hours, but the industry built an entire certification system to convince you that this simple task requires professional expertise, liability insurance, and code compliance only licensed contractors can provide. The global insulation industry generates $190 billion in annual revenue. Companies like Owens Corning, Johns Manville, Knauf Insulation, and CertainTeed dominate the market with products designed for one purpose: recurring sales. Fiberglass bats settle and lose effectiveness within 10 years, requiring replacement. Spray foam degrades from moisture exposure and needs reapplication. Blown-in cellulose compacts over time, creating gaps that require additional material. Every single mainstream insulation product follows the same business model. Sell the initial installation, then generate service calls, inspections, and replacement cycles for the next 30 years. That is not a product. That is a subscription disguised as construction material. Reflective barriers destroy this entire model. Aluminum does not settle. It does not absorb moisture. It does not degrade from temperature fluctuations. It does not require maintenance. A properly installed reflective barrier lasts as long as the structure itself. That might be 50 years. That might be a century. The material costs $2 to $4 per square foot. Installation requires no special equipment, no protective gear, no training, and no licensing. A homeowner can insulate an entire attic in one weekend with materials costing under $100. Compare that to blown-in insulation costing $2,000 installed, requiring replacement every 12 to 15 years. Over 30 years, the reflective barrier costs $100 total. The blown-in insulation costs $6,000, including 2 replacement cycles. The insulation industry cannot allow that comparison to become common knowledge, so they did what every threatened industry does. They captured the regulatory system. In 38 states, building codes now specify minimum R values that can only be achieved through bulk insulation products. Reflective barriers are either prohibited outright or relegated to supplemental use only. The stated justification is fire safety and structural integrity. The actual reason is market protection. Trade associations representing insulation manufacturers fund the committees that write these codes. The same companies sponsor the training programs that certify building inspectors. They provide the continuing education courses that maintain contractor licenses. The entire regulatory apparatus exists to eliminate alternatives that threaten industry profits. Here is the part that should make every homeowner genuinely angry. The Department of Energy published comprehensive studies proving reflective barriers outperform traditional insulation in most climate zones. Those studies are publicly available. But when you call a licensed insulation contractor and ask about radiant barriers, 90% of them will either dismiss the technology as ineffective or quote, prices 3 to 5 times higher than bulk insulation. They have been trained through industry certification programs to steer customers toward products that generate long-term revenue. The contractor is not lying to you maliciously. They genuinely believe what they were taught, but what they were taught came directly from manufacturers who profit from complexity, degradation, and replacement cycles. If you have made it this far, you already know more about thermal dynamics than 99% of licensed contractors in North America. Subscribe and share this with someone who needs to remember what the insulation industry made us all forget. Everything they buried is inside the complete vault, including installation diagrams, material specifications, and climate-specific techniques. The link is in the description. Now stay with me, because the next part is the heaviest. Here is exactly how to install a reflective barrier system that will cut your heating costs by 60 to 70% using materials you can buy this afternoon. You need aluminum foil insulation, also called radiant barrier foil. This is not standard kitchen foil. This is reinforced foil laminated to craft paper or plastic backing for durability. You can find it at any Home Depot, Lowe's, or building supply store. A 500 square foot roll costs between $40 and $70. You also need a heavy-duty staple gun, a utility knife, and aluminum foil tape for sealing seams. Total material cost for a typical 1,500 square foot attic runs $120 to $180. Step 1. Measure your attic floor area to calculate material requirements. Add 15% for overlap and waste. Step 2. Clean the attic space, removing any debris or existing damaged insulation. You want a relatively clean surface to work with. Step 3. Starting at one end of the attic, roll out the reflective barrier perpendicular to the ceiling joists. The shiny aluminum surface must face downward toward your living space, with a minimum 3/4 inch air gap between the foil and the ceiling below. This air gap is absolutely critical. Without it, radiant heat can conduct through direct contact and the system loses 70% of its effectiveness. Step 4. Staple the barrier to the underside of the roof rafters, maintaining that 3/4 inch gap consistently. Staple every 12 inches along each rafter. Step 5. Overlap each new strip by 2 inches and seal the seam with aluminum foil tape. No gaps. Every opening allows radiant heat to escape. Step 6. Cut the material carefully around obstructions like vent pipes and electrical boxes. Seal those edges with foil tape. Step 7. In walls, you can install reflective barriers behind drywall during renovation or construction. The same principle applies. Shiny side toward the living space with a 3/4 inch air gap. A homeowner in Montana did exactly this in November 2019. His 2,000 square foot home was costing $430 per month to heat during winter. He spent $150 on radiant barrier material and installed it over 2 weekends. His heating bill dropped to $170 per month. That is $260 saved monthly or $3,120 annually. The material paid for itself in the first 3 weeks. By the end of year 5, he will have saved over $15,000. His local contractor had quoted $2,800 for blown-in cellulose insulation that would need replacement within 15 years. Instead, he installed a system that will function for the life of his home with zero maintenance and zero degradation. Compare that to standard fiberglass batt insulation. A 1,500 square foot attic requires roughly 30 batts of R30 insulation at $12 each. Material cost is $360. Professional installation adds another $800 to $1,200. Total cost is $1,100 to $1,500. That insulation will settle by 30% within 10 years, losing effectiveness and requiring either replacement or supplemental material. Over 30 years, you are looking at 2 to 3 replacement cycles. Total cost approaches $4,000. The reflective barrier cost $150 installed once and never needs replacement. The savings are not marginal, they are overwhelming. Here's what you need to know about effectiveness in different climates. Reflective barriers work best in extreme temperature differentials. If you live in Minnesota, Alaska, Montana, North Dakota, or anywhere with sustained sub-zero winters, radiant barriers will provide maximum benefit. In moderate climates like Virginia or Tennessee, you will still see 40 to 50% heating cost reduction. In warm climates like Arizona or Texas, the same barriers work in reverse during summer, reflecting heat away from your living space and reducing cooling costs by similar percentages. The physics works identically, regardless of whether you are keeping heat in or keeping heat out. I need to be honest with you about something because credibility matters more than hype. Reflective barriers are not perfect. They require proper installation with consistent air gaps to function at maximum efficiency. If the foil contacts the surface it is supposed to reflect heat away from, effectiveness drops significantly. Dust accumulation on the reflective surface can reduce performance by 10 to 15% over many years, though this is easily addressed by wiping the surface during routine attic maintenance. And reflective barriers do not address air leakage. If your home has significant gaps around windows, doors, or penetrations, you need to seal those separately. Radiant barriers stop radiant heat, they do not stop airflow, but here is what matters. This is survival insulation, not commercial marketing. Your great-grandparents did not optimize for zero maintenance. They optimized for what works. A material that requires wiping dust every 5 years and saves $3,000 annually is not a compromise. It is a solution that prioritizes effectiveness over convenience. In 2400 BC, metalworkers in Cyprus discovered that polished bronze redirected heat. In 400 BC, Greek engineers lined bathhouses with copper. In 1200 AD, medieval builders installed tin behind castle fireplaces. In 1908, Sears Roebuck sold reflective radiator shields to every homeowner in America. In 1985, Oak Ridge National Laboratory proved radiant barriers outperform R19 fiberglass by 40%. In 2024, NASA uses multi-layer aluminum insulation on every spacecraft. And yet, a $190 billion industry would rather sell you products that degrade every decade than acknowledge a $2 material that works better and lasts forever. This knowledge did not die. It was waiting in engineering journals, in NASA technical documents, in the actual construction of buildings over 2,000 years old that still stand because their builders understood physics. And now, sitting right here, watching this video, you just reclaimed it. If this vault opened something for you, subscribe and share it. Every share preserves what the industry spent decades trying to erase. Every person who learns this is one less customer they can count on. The next vault opens soon. What is inside is even heavier than what we uncovered today.